The outline of this presentation it will lay a framework for assessing or evaluating, say, other practices that are in place for other parallel problems which are, quote, similar to cyber assurance, and show how that they may be applied to bringing a structure and a framework to cyber risk assurance. We'll review we'll review cyber first in terms of an overview of why it's different, how that parallels to other practices, and then introduce CMM framework, capability maturity model framework from Carnegie Mellon, introduce the role of standards and what standards can play and how they could be applicable at this point in the cyber development process, and then finally to bring in other tools such as tools that were developed around Sarbanes-Oxley and a process called a control matrix for evaluating and assuring practices. I realize that's kind of a high-level overview, kind of a mouthful in terms of topics, but hopefully they'll come together. Okay, cyber is. There are two basic things about cyber. First, it's emerging very quickly, as it has moved over the arc of visibility over the last 30 or 40 years, to the point that it is now the basis of nearly all transactions that we perform. This webinar is being performed by cyber infrastructure, purchase of Christmas goods online, and then if you use brick and mortar institutions, the stocking and tracking of institutions or material in that space, basically movement of material. Basis of all communications, nearly all communications today is digital. The majority of any analog and minor control has been moved into the digital space. And then more recently, in terms of smart devices, or the everywhere internet concept, local TV, in terms of our modules that display from institutions or other organizations such as direct live TV, et cetera, devices that we carry with us, and then now what's emerging is the internet in the home, and all the connectivity of those devices, and finally the point that those devices are interconnected. The TV has the potential to be connected to our toaster. And having said all that, the quality of knowledge over this about making it work from a control perspective is at just an emerging level. Prevents two classes of risk. One is malfeasance, that is risks that are intended. The intent is to subvert or convert, and that includes intentional abuse and intentional attack. I'll mention one example, but there are obviously this is the press in terms of regularly, weekly, there are significant issues. And then finally, misfeasance, and this is equally the majority of the outlier issues that have been concerned are in fact bug issues, or what are reported as errors. And many of those can go, both of these can go undetected for a significant period of time. So recent example for malfeasance came up just last week was the Regan rootkit. That's been known for several years now. It was not reported because it was thought that it was assumed to be part of an infrastructure process. It's stealth. This opens up a whole category of attributes around cyber and cyber issues. It's very sophisticated. Its whole intent was to lie dormant and to not be visible, so it protected itself. But its purpose was to essentially perform espionage, and by espionage I mean to track and report usage. And other similar bugs or other similar characteristics of this, of course, were the famous Stuxnet virus that was inserted and used to manage or control Iranian nuclear centrifuges. In the area of misfeasance, one that came again also last week was the reported issues around significant deterioration in the control structure around nuclear missile management in the Air Force. And this was a significant issue that arose primarily from underfunding and undertraining. Again, both areas of unintended consequences. The result was loss of effective controls around devices, and a whole set of system level controls around assurance and personnel management. But equally, but significant in this is a usage of cyber to one reported outcome of this, where in fact nuclear warheads were essentially transferred across the country uncontrolled. And again, that's a cyber issue in terms of using the infrastructure that's in place to create that occurrence. So, given that as a background, what do we have to put in place to address this? Now we'll get to a bit of an outline of the presentation. So we'll review the scope of cyber in a little more detail than we've just covered. Second, we'll introduce the concept of process maturity. This is copied directly from the capability maturity model developed for Software Engineering Institute at Carnegie Mellon, and the outcome of that, or the primary role of that, and the transfer to this is really two transfers that are applicable to cyber. The first is the concept of what I'll call a meta model around control attributes that are directly attributable to cyber. But the second, and this is something that's I think a transfer that is equally important or significant, is the concept of the role of metrics in terms of understanding. When I say metrics, I mean metrics around not the implementation of cyber, but metrics around the ability to measure how effective a cyber control process is. With the potential role of standards, standards typically are a lagging implementation. That is, they follow once a process is mature, and cyber is emerging. Therefore, it's a bit I'll say out of sync. But there is a significant role in a significant number of areas where standards, it's now appropriate to introduce standards. One of those is, say, it would be around siloed functions, which are relatively mature. And the second would be a standards infrastructure in terms of creating a standard around control and attribute and identification. And then we'll introduce the concept of risk management. This is again a lifted or a stolen function from managing other areas, and it's a direct of a risk control structure to cyber. Not to spend too much time on this because we're all aware of it and we hear it basically every day, but cyber is pervasive. It is just a simple example of I purchased a small item, a $5 item online. That item, the purchasing of that item, the introduction of that item into the transport mechanism, in this case the U.S. Postal Service, the tracking of it all the way through, and finally the arrival at my door is all cyber run. That application wasn't introduced so that I could do that. The most important point of this is that capability became in place because it was necessary for the Postal Service to compete to create that level of control around the tracking of that package, and the availability of that information was an outfall, not an objective. In other words, it was their control that made that application necessary. Cyber is embedded across the line. It's in our phones. It's in our cars. It's in, as I said earlier, it's in our TV set, and soon it's going to be in our toasters. It's in baby monitors, the ability to track and manage security, et cetera.